Hello, and today I'd like to go over the geometric representation of imaginary numbers. In Algebra 2, you probably learned that the imaginary number I is equal to the square root of -1. So for negative 144, you would get -1 and 144, for the square root of 144 equaling 12, and the square root of -1 equaling I. So you'd get I12 or 12I. Now the way I would like you to see this is by taking a number line. Let's say you have 2 times -1. Well, that gives you -2, and you do an 180-degree turn on the number line, or a half circle. Now, let's say you have an imaginary number. So let's say 2 times I. Well, that would give you 2I. And the amazing thing is, this is actually represented as a 90-degree turn on the imaginary number line. Likewise, I to the power of 2 would then equal -1, as represented by a 180-degree turn, and then I to the power of 3 being 3/4 of a circle, and I to the power of 4 returning back to 1. Let's solve a practice problem. So let's say you have 4 times I squared. Well, that would be 4 times -1, meaning you have a 180-degree turn to -4. Let's say you have an algebraic problem, so 11I times 4I. Well, that would just be -44 after you factor out and solve for I. One practice problem I want you to do is 13 times I squared times 17I. Go ahead and pause the video and try it for yourself. And for our final recap, you can go ahead and look at the i's and their powers. Remember, geometrically, these go in a full circle, meaning that you actually have recurring values for i's to different powers.